This will resembles to the musical note, that is sa re ga ma pa da ni. Again the sa will be resembled for the first sa. The elements in which the last electron enters the p subshell of their outermost energy level are called p block elements. Here beryllium, magnesium, calcium are having similar properties of physical and chemical properties. Hello my dear students, I am Harshita Bhavsar from Vidhyaashram PU College. Today I shall explain the new chapter, that is classification of elements and periodicity in properties. First we will see the exam corner or the weightage of marks allotted to this chapter. Okay. The number of hours have taken or allotted for this chapter is 5 hours. In part A, that is 1 mark question, one question should be allotted, and here you know that all questions should be answered. So 1 mark questions, whatever it will be under this chapter, get prepared. And 1 3 mark question, that is in the number of question number 19, you will get 1 question. Total marks allotted is 3 plus 1 is 4. Okay. The 4 marks is the weightage of marks allotted for this chapter. In this session, we will see the genesis of periodic classification, the modern periodic law and the present form of periodic table, electronic configuration of modern periodic table, classification of the periodic table into blocks. These are the contents today we are going to be discussed. So first, we will see what is the genesis or the introduction part. In the chemistry, one of the greatest achievement is the periodic table, right? In the periodic table, we know there are lots of information about physical properties and chemical properties of elements. For the existence of the periodic table, there are lots of or various scientists have made efforts to the outcome of the periodic table. Okay. So first we'll see the genesis of the periodic table. The first scientist is Dauvergne. In the 1829, a German scientist, he is a Dauvergne. He put forward a law of triads. Okay. According to the law of triads, 3 chemically related elements were grouped. 3 chemically related elements were grouped. That is we'll call it as triad. That we will call it as triad. That is 3 chemically related elements. Okay. What is it mean means the atomic weight of the middle element was the mean of the atomic weight of an other 2 elements. Here he is considering the atomic weight. He is considering the atomic weight of the elements. What he is telling means the middle element will be the mean of the atomic weight of other 2 elements. Means if we are considering this triad, this one triad, he will add up these 2 atomic weights of the elements and he will do the divided by 2, then he will get this number. The middle atomic weight he will get after the calculation. Okay. That is what the meaning of the statement of the law of triads. Also the properties of the middle element were in between those of the other 2 members. These elemental properties, that is physical and chemical properties, will be in between the other 2 elements. Means this property also little bit will be belonged and this elemental property also it will be having. So in between the other 2 elements. These are the whole thing what the statement of the law of triads. Okay. We will see the another triad, calcium, strontium, barium. Here the first triad is lithium, sodium, potassium. Okay. This is the atomic weight of lithium, this is the atomic weight of sodium and atomic weight of potassium. We will consider another triad, calcium, strontium, barium. What he did, the exact what he did means, here 40.1 plus 137.3 divided by 2. Overall, he will get 87.6. Similarly, he took another triad, chlorine, bromine, iodine, 35.5 plus 126.9 divided by 2, that is 79.9. Okay. Whatever the calculated product, what he will get, it will be similar or same as to the middle element, and also the property also. Okay. This is the law of triad, came from Daubernier. Okay. And also this experiment or this law of triad could not be allotted for every element. So the failure of Daubernier can be seen here. Next, we will see the NEWLAND'S law of octaves. In 1865, John Alexander Newland, he proposed the law of octaves. What he told, the elements were arranged in the increasing order of their atomic weight, and every 8 element had similar physical and chemical properties as that of first element. Okay. He also grouped some elements here. What he did, first element should be have the relation for 8th element, means the physical properties and chemical properties of the first element should be related to the 8th element, and this will resembles to the musical note, that is sa re ga ma pa da ni. Again the sa will be resembled for the first sa. Like that, the first element will be resembled to the 8th element. That is what he told. This was similar to every 8th musical note is the repetition of the first one of the musical scale. Okay. The overall properties of first element will be resembled to 8th element, and this element will be resembled to this. Same thing, lithium, sodium and potassium are the similar properties having. Okay. Here beryllium, magnesium, calcium are having similar properties of physical and chemical properties. And here boron and aluminium, carbon and silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine and chlorine. If you see the modern periodic table, the similarities of the elements could be seen in the modern periodic table also. What they have done means, they have taken all the points from the previous experiments and later they have developed the modern periodic table. Okay. But what is the failure or the drawback of this experiment means, this law is applicable up to only calcium. After the calcium, the element calcium, he could not predict the same properties what he has shown here. So, this is the failure of the law of octaves. Okay. Next, Mendeleev's classification of elements. Dmitry Mendeleev, he is a Russian scientist who proposed the classification of elements, or he proposed the Mendeleev periodic law. What he told, the properties of elements are a periodic function of their atomic weights. On the basis of the elemental atomic weights, it will show the periodic function. Okay, that will be the statement of Mendeleev's periodic table. Mendeleev arranged the elements in increasing order of their atomic weights in horizontal rows called periods and the vertical columns called groups, so that the elements with similar properties occupied the same group. Okay, like this periods he showed. If it is like this, it will be groups, means horizontal rows called periods, vertical columns called groups. The similar properties of elements will be in the same group. Okay. This is the periodic table of Mendeleev. What he did? He started from the 0 group to 8th group. Okay. This is the periods, the overall periods, and this is groups. Okay. This is 0th group, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th and 8th. As he told, similar elemental properties having the elements will be grouped one by one below. He has left some spaces here. Here is some space, here is also so many spaces are present, like that. Why he left the spaces means, At his time, he has thought of or he predicted some elements yet to be discovered. So he left spaces whichever yet to be discovered, later on they could have been established in that place. So he left that spaces, okay. Like as he thought, here gallium and germanium is there. At that time it was not discovered in the time of Mendeleev. Later on it discovered, that named was eka aluminium, later it named as gallium, and here eka silicon they gave the name, later it named as germanium, okay. This was the merits also we could have told, and why they have been put it in the below of aluminium means it has the resemblance of the aluminium or the properties of aluminium and also silicon. We'll see the merits here. The study of elements made easy as similar properties are arranged in the same group. What he told? Why he has arranged in one below the one means the elements are having same properties will be seen in one group. By seeing that group itself, we can assume that, oh, these groups are in having the same properties or similar properties. Mendeleev has left some vacant spaces for yet to be discovered element. Example, he left space for gallium named as eka aluminium and for germanium named it as eka silicon. Before it was in a name eka aluminium and eka silicon, later it named for gallium and germanium. The elements discovered were later and the properties predicted by the Mendeleev's were found to be correct. What he thought before, it came into existence and it was true also. Next, modern periodic law and the present form of periodic table. After all the three or more scientists who came and who made the efforts of periodic table, later from their points, in 1913, Henry Moseley proved by the experiment that atomic number is the most fundamental property than that of atomic weight. Before three scientists, what they have considered only atomic weight. But the one who scientist Henry Moseley, he told first, that is atomic number is the fundamental property than that of atomic weight. Then what does it means that law will call it as modern periodic law. The physical and chemical properties of elements are the periodic function of their atomic number. This statement was same in Mendeleev's law, but what he told? Atomic weight is the periodic function. Here Henry is telling that atomic number is the periodic function. A modern version, so-called long form of periodic table of the elements, is the most convenient and widely used. Whatever now we are following the modern periodic table has been widely used and convenient to remember its properties also, convenient to remember the whole elemental properties also. Okay. This is the periodic table of the elements. Okay. The present form what we are seeing in our studies, this is the table. First we have to understand how it will be named, because we have to identify the each and every element, right? So, in the every block means in this each box, symbol will be present, symbol of element will be present, and atomic number, atomic mass and name. These are the content of the element present in the each box. Okay. This is name, atomic mass, atomic number. In some of them periodic table we could not see the name, but nowadays they are publishing name also below that. Main thing is atomic number, symbol and atomic mass will be present. And the overall modern periodic table has been given here and they have periods and groups also. See here, whatever the horizontal rows, okay, that is periods. Those we will call it as periods, and the vertical columns will be called as groups. Then how many periods are there? 1, 2, 3, 4, 5, 6, 7. Overall 7 periods. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 groups are present. Okay. This is the basic thing of periodic table. And also we have divided into 4 blocks. That is 1 and 2 group will be known as S block element, S block. From 13 to 18 will named as P block. This group 3 to group 12 will call it as D block. This F block will belongs to D block only. Okay. I will explain in the next slide, but this will be belongs to D block, but they have taken out and put it in the downside. We will call it as this block as F block series. Okay. And also this first block, what is S block, there are 2 periods. This will be call it as first A group will call it as alkali metals. This second one will call it as alkaline earth metals. This one 18th group will call it as noble gases. This will be called as halogens, and similar like this properties we have more. Okay. And we have given here, see the pink color shade alkali metals. This is yellow alkaline earth metal. This D block will also called as transition metals. Okay. And the green thing here, whatever the present here, this is basic metals. And the zigzag manner, what we are seeing here, the blue color are metalloids. Here, the non-metals, this is, we'll call it as halogens, and this is noble gases which are in the gaseous state. This is lanthanoids and this is actinoids. Okay, F block is divided into lanthanoids and actinoids. This is the overall basic content. By seeing itself, we can know the whole thing. Okay. And also, we have to know that which period is the long and which period is the short, like that. In the first period, if you see, only 2 elements are present. This is the shortest period in the periodic table. Okay. In the second period, if you see, there are 8 elements. That orbital or that period is containing only 8 elements. This is also a short period. And third period will be having again 8 elements. And next, if we see the fourth period, we are having the middle range period. See here, lengthiness of the period we can observe here. Again, fifth also same thing. Sixth and 7th period is the longest period. Why? Because this F block is taken from here. This is 6th period we have taken from here. This is the 7th period we have taken from here. Okay. See here, the atomic number is 57. This is the lanthanum. It will be placed here. We have taken next 58 to 71. This is 58 to 71. Later it will start 72, 73, 74. If it is here only, this is the lengthiest form and the longest form in the whole periodic table. Same thing, 89 is here, 89 actinium, again 90, 91, 92 till 103 lawrencium is there. After 103, 104, 105, 106, 107, like that it will keep on continuing. Okay. This is also taken from 89 to 103 has kept below. Okay. Since the series will start from the lanthanum element, the whole series will called as lanthanoids. Similarly, here the first element is actinium. The following elements will follow the actinium. So, the whole series will called as actinoid series. Okay. This is the whole thing or the basic content of the periodic table. Next, we will see the electronic configuration of the periodic table. We have seen in the previous chapter how to do the electronic configuration by seeing the element with its atomic number and how the orbitals are arranged, right. We know that periodic table is divided into 4 blocks, that is S, P, D and F block. Okay. Here 1s, the whole element will belongs to 1s orbital. This is second period will belongs to 2s and 2p. Third period 3s and 3p. Overall, next fourth period will belongs to 4s, 3d, 4p orbitals. Next fifth period element will belongs to 5s, 4d, 5p. Sixth period 6s, 5d, 6p. Seventh period 7s, 6d, 7p. Also 4f and 5f, right. Here again we'll separate this one. Why means these are the transition metals. We'll call it as 3d series, 4d series, 5d series and 6d series. Each series will be having 10 elements and those series will be called according to their period number. 3d series transition metals, 4d transition metals or series, like that we will name. Okay. And this is about the electronic configuration of the modern periodic table and which element will be having or which belongs to the subshell we are knowing into it. Next one, classification of the periodic table into blocks. First we will see the S block elements. Its general electronic configuration is NS 1 to 2, that is not minus, 1 to 2. This N will be can 1s, 2s, 3s, 4s, 5, 6 and 7. N can be anything from this. Okay. The elements in which the last electron enters the S subshell of their outermost energy level are called S block elements. The outermost or the last electron will be entered to S subshell, then the elements belong to S subshell will call it as S block elements. Elements of the group 1 will call it as alkali metals and group 2 will call it as alkaline earth metals belonging to this group. See here, group 1 alkali metals, group 2 alkaline earth metals. We will see its characteristics. They are soft metals. They are metals but they are soft in nature. They have low ionization enthalpy. First we will see the ionization enthalpy. Enthalpy means energy, we know that. The energy required to remove the electron, we will call it as ionization enthalpy. But for this group, it is having in low. Okay. They show oxidation state of +1 in alkali metals, +2 in alkaline earth metals. What do you mean by oxidation state means? If we take an example, first we will see in first A group, we will take sodium, its atomic number is 11. We will write the electronic configuration 1s2, 2s2, 2p, 6 overall, 10, then 3s1, right. 2, 4 plus 6 is 10, 11. If we remove this outermost electron, what will happen? It will become a cation, Na plus, right. Since it is a low ionization enthalpy, we can remove only one electron from the outermost, then the element will be having +1 oxidation state. We know that only first 1A group will be having +1 oxidation state. If we take any element from the group 2, we will be having +2. We have to remove the outermost electrons. Okay. The metallic character and the reactivity increases as we go down the group. The metallic character means the hardness or any other metallic character will be increased as we down the group and also the reactivity will be increased. S block elements are predominantly ionic in nature except beryllium and lithium which show covalent in nature. Except this beryllium and lithium, All the other elements will show ionic in nature. These two will show covalent in nature. These are the kinds of bonds which we will see in chemical bonds, types of chemical bonds, but we will discuss in the other chapters. Okay. Now you have to understand the basic characteristics of the each block. That's why we are discussing these things. Okay. Next, p block elements. Its general electronic configuration is Ns2, Np, 1 to 6. The elements in which the last electron enters the p subshell of their outermost energy level are called p block elements. Okay. The last electron will be entered to the p subshell. Those elements will call it as p block elements. Elements of the group 13 to group 18 belonging to this group. See here, this is group 13 to overall group 18 will belongs to p block elements. What are the characteristics? They include both metals and non-metals. We have told already, this is basic metals. Whatever here, these are basic metals. This is non-metals, and whatever the zigzag form is there, this is metalloids. Means it will show both metallic character as well as non-metallic character. That's why we'll call it as the term metalloids. Okay. The metallic character increases as we go down the group. In each group, as we go down the group, the metallic character will be increased. Most of the elements show variable oxidation states. Okay, here so many various oxidation states can be seen in this group. Elements present in the group 18 called as noble gas, 17 called halogens. Elements present in group 16 will call it as chalcogens. This is group 18, we'll call it as noble gases, group 17 halogens, group 16 chalcogens. Overall, S and P block will be called it as representative elements. The elements from the block, from the S block and the P block will collectively called as representative elements. Next, D block. This is the general electronic configuration. The elements in which the last electron enters the D subshell of their penultimate energy level are called D block elements. Okay, I shall explain what is penultimate energy level. So, if we take the manganese, its atomic number is 25, right? We'll write the first electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 320, next 25. If we add, we will get overall 25. See here, this is the outermost energy, right? 4s is the outermost energy, but the last electron is reaching the, that is 3D orbital. This is the outermost energy level. This is the last but first energy level. In the T block elements, all the elements, the last electron will reach the last but one orbital. That's why we'll call it as penultimate energy level. The last but one. Okay, I hope you have understood. See here, once again I am telling, this is the innermost. There is no need to observe these things. 4s is the outermost energy level, we know that. 3D is the before that, right? But in the D block elements, it's reaching the last electron to the 3D element rather than 4s. The 4s will be first only filled. Later, the 3D will be filled. So, we'll call it as penultimate energy level. Here, the elements of the group 3 to 12 will be belonging to this block. See here, this is the third group to overall 12th group. Next will be starting from P block, right? The third group to 12th group, we'll call it as D block elements, and it is also known as transition elements or transition metals we will called. Okay, this one 3D series, 4D, 5D and 6D series. Okay. Next, the general characteristics. They are metals with high melting point and boiling point. We know the metals characteristics. Metals will be having the high boiling point and high melting point. They form colored complexes. In the formation of complexes, it will show various colors. Okay. They show variable oxidation states. They show paramagnetism. Paramagnetism means the electrons will attracted towards the magnetic field. That property will call it as paramagnetism. A large number of D block elements such as iron, nickel, cobalt, manganese, palladium, platinum, vanadium act as a catalyst. Okay. We know the catalyst, it will be increases or decreases the rate of reaction. In this elements or in this block, these elements or more than these elements act as a catalyst property. Next will be F block elements. This is the general electronic configuration. The elements in which the last electron enters the n-2 F subshell, okay, of their energy level are called as F block elements. Elements of the group 3 to 12 belonging to this block. Here also same 3 to 12 only it will belongs. They are known as inner transition elements. Why it is inner transition? It will also belongs to transition series, but it has been taken out from the transition series and they have kept outside. But it will be in inner side of the transition series. They consist of two series of elements placed in the bottom of the periodic table. These are the two series. The first series follows lanthanum. Atomic number is 57. Hence it is called as lanthanoids. Here, see here, cerium to lutetium. The 57 lanthanum will be seen in D block. After that will be continued 58 to 71. It has kept separate. That's why this series, the overall, this series will call it as lanthanoids. Okay. And next, the second series follows actinium. The atomic number is 89. It will be in the D block. It will follows the 90, that is thorium, to lawrencium, that is 103. Its atomic number is 103. Since the first element is actinium, we'll call it as, the series will call it as actinoids. Okay. These are the basic things of the classification of blocks into the periodic table, and about D and F block elements will be read in completely in your next classes. Okay. I hope you have understood this session. In the next session, we will see the nomenclature of elements with the atomic number above 100, periodic trends in the properties of elements. Okay. These are the contents or these are the objectives will be covered in the next session. So, thank you everyone.